Hello students, in this video we'll discuss Bernoulli random variables. A random variable x, which maps a sample space S into R, is called a Bernoulli P random variable if the sample space S can be partitioned into two sets E intersect E complement, and on E X outputs 1, and on E complement X outputs 0, with the probability of the event E being equal to P, and then consequently, if that's so, then the probability of E complement has to be 1 minus P. Of course, the probability of E complement is therefore 1 minus P. And so what we can do is we can write the random variable in the following way. We can write this Bernoulli random variable x as being equal to 1 on the set E with probability P, and 0 on E complement with the probability of E complement being 1 minus P. And so what we can do now is we can compute the expected value of these random variables. So some remarks on these. Remark: the expected value of x can be computed as follows. Well, and we have expected value of this random variable x will be 1 times P plus 0 times 1 minus P, so we just have P, where of course we've used the formula, this is just the sum over all A, such that the probability mass function of the Bernoulli random variable is not equal to 0 of x times A times P of A. A times P of A. And there's really only one sort of event where we're focused on, that's on the event when you're at 1. So we have the expected value as P, and now we can compute the variance of this random variable. So if we look at the variance of x, the variance of x is of course the expected value of x squared minus the expected value of x quantity squared. And so now we see that this will also be, what we'll have over here is the expected value of x squared. Well, what's x squared? Well, x squared is going to be 1 will be 1 on the set E and 0 on E complement. And so what will happen here is we'll have a P for the expected value of x squared, and then we'll have minus the expected value of x quantity squared. So the expected value of x quantity squared is going to be P squared. So we can factor a P out of that and have P1 minus P is our variance. So what we can say succinctly is that the mean of Bernoulli P is P, and the variance of Bernoulli P is P times 1 minus P. Now, as one further remark on these Bernoulli random variables, what we can do is if we consider, so if x is Bernoulli P, then what we can do is we can consider the new random variable, which is going to be A plus B minus A x. And what this random variable will be is this random variable will be A on E, because if x is equal to, it will be a on E complement, so it'll be an E complement. Because if x is 0, so we know that x is 0 on E complement, so on E complement, this first term, this x term will be 0 and just have a, so this will be on E complement. And then when x is equal to 1 on E, then this will be a b minus a, and then plus a, so that will give me a b on E. So if you have a random variable that takes on exactly 2 values, you can write it as a linear combination of a Bernoulli random variable and a constant. Thank you very much.